Howdy there, Mr. Sutton with the IM23 Honors 3-5 homework answers for surface area and volume. For number 1, we want the lateral surface area of this rectangular prism. So we need the rectangular prism lateral surface area formula, which is 2 times height times width plus 2 times length times width. So let's see, we have a height of 9 and a width of 12, so we have 2 times 9 times 12 plus 2 times length, that's 2 times 4 times the height of 9. And if they don't tell you specifically that one side or the other is the base, then we'll just assume that the bottom and the top are the bases. So we're just finding the non-base areas here. So multiplying all that out, I've entered it in my calculator here. Calculator says 288. What kind of units? Well, we're doing surface area with inches, so that's 288 square inches. For number 2, we want the lateral surface area of this square pyramid. So for that, we have the formula 2SL, where S is the side of the pyramid and L is the slant height, which they were kind enough to give us. We didn't even have to work for that. So this is just going to be then 2 times 145 times 327, and that's a calculator question. That's going to come out to 94,830, and that's going to be in square feet. For number 3, we want lateral surface area of this cone. So that's formula, we're going to have pi RL. So we have a radius of 5. They gave us the slant height of 10. So we've got pi times 5 times 10. And on the calculator, that comes out to about 157.1. And that's going to be in square centimeters. For number 4, they want the surface area of this cylinder. And since they didn't say lateral, they mean the total surface area. So we need that formula. That's going to be 2 pi RH plus 2 pi R squared, or vice versa. Either way, we've got the area of the two bases plus the lateral area here. So we have a radius of, well, they gave us the diameter of 22, so the radius then must be half of that, 11. So radius of 11, height is 8, so 2 times pi times 11 squared plus 2 times pi times 11 times 8. Calculator time. So there we go, entering all that at once. We come up with 1,313.2 square centimeters. For number 5, we're trying to find the surface area of this sphere. So we'll use our surface area formula, 4 pi r squared. The radius they gave us, that's 7.5. Plugging that in the calculator here. That's going to come out to 706.9, and that's going to be square centimeters. For number 6, we want the surface area of this weird kind of silo-shaped figure. So there's actually 2 surface areas we need to find. We need the surface area of the cylinder, and when I say surface area, I mean we definitely need this base. We do not need this other base, though, so we'll talk about how to adjust for that in a minute. We also need the surface area, just the lateral surface area of this hemisphere. So getting back to the cylinder, we only want one of those bases. So instead of doing 2 pi r squared plus 2 pi r h, we're going to do 1 pi r squared plus 2 pi r h. This only gives us one of those circular bases. Plugging in our radius now, we had a radius of 5.8, so pi times 5.8 squared, plus 2 pi times 5.8 times the height is this 14 feet. So let's use the calculator now. Plugging all that in, and here's the rest of it, got kind of cut off there. We have about 615.9, and that's what, square feet? So we'll put the units on there in a second. Now for the hemisphere, we have to do half of the surface area of a regular sphere, so 4 pi r squared divided by 2. And you could simplify this to 2 pi r squared, but I'm just going to go ahead and plug in the radius of 5.8 and go from there. And we'll use the calculator again. So 4 pi 5.8 squared divided by 2, giving us 211.4. And then if we add those two things together to get the total surface area, that's going to come out to about 827.3 square feet. For number 7, we want the volume of this shape, which turns out to be a cube because all the sides are the same. So we're going to do volume equals side cubed. We're just going to do 8 cubed then, and we can use the calculator for this. So plugging that in, that comes out to 512, and that's going to be centimeters cubed. For number 8, we have the volume we're trying to find for this cube with a cone hollowed out of it. So to do this, let's first find the area, or the volume rather, of the cube. That's going to be side cubed, or 5.1 cubed. Using our calculator, we get, it looks like 132.65. And I'll take it out to 2 decimals. That way when I add or subtract whatever things at the end, I can get to my 1 decimal of required accuracy on this. All right, so now we need to figure out the volume of the cone. And remember, we're going to subtract this from the volume of the cube because the cone is being taken out of here. So this is in general 1/3 pi r squared h. We have a radius of, well, we don't know the radius. They didn't give it to us. But we know that the diameter all the way across here is going to be the same length as one of these cube sides. So 5.1 divided by 2 then would give us our radius. And then we have a height that is the same as the side of the cube, 5.1. So this 5.1 is getting a lot of use here. So let's plug all that in now. So I've got my 1/3, I've got my pi, my 5.1 divided by 2 squared, and we're multiplying again by this 5.1 over here, giving us a grand total of about 34.73. And let's just subtract these now to get the volume of all the stuff that's not the cone inside that cube. Subtracting that out, I get about 97.9 if I round off to the nearest tenth, and that's going to be in cubic meters. For number 9, we have a right square pyramid with the following dimensions. Side length of the base is 5 inches, height is 9 inches, and we want the volume of the pyramid. So let's start by writing our volume formula. If you look it up, that's going to be 1/3 s squared h. And then we know that the side length of the base is 5, so s is going to be 5. Height is going to be 9. Plug in all that in. We could do this without a calculator. 1/3 of 9 is 3, times 25 gives us 75 cubic inches. Choice A. For number 10, cube has a volume of 725 cubic centimeters. Which of the following is closest to the length of each edge of the cube? So we know that volume equals s cubed for a cube. This time they're giving us the volume, so we have 725 equals s cubed. And to actually find the side, we have to cube root both sides. If you have a calculator and you're allowed to use it, then this is a very quick problem. If you didn't have a calculator, what you could do is multiply these out. Maybe you know what they are cubed, or do it by hand. So 7 cubed is 343. 8 cubed, we saw that earlier in the homework, that's 512. But you could multiply it out by hand. 9 cubed, that's 9 times 81, which is 729. And then this last one here, 10 cubed, that's 1,000. So the closest one to 725 is 729. So that means this is closest to 9, which would give us choice C. For number 11, the core of a baseball is in the shape of a sphere. Diameter of the core is 2.06 centimeters. Which of the following is closest to the volume of the core? So volume of a sphere in general, that's 4/3 pi r cubed. The radius in this case will be half the diameter, so 1.03 centimeters getting plugged in there. And we'll need the calculator for this. Plug in all that in, we get 4.58, and that's going to be cubic centimeters. Choice B. For number 12, Terrell designed the original external fuel tank for a spacecraft. The tank is in the shape of a right circular cylinder, as shown below. We want to know the radius in feet of this tank, and show how, or explain how you got the answer. So they gave us the diameter of the tank, which is 30. Radius will be half of that. So half of 30 then gives us 15, and that's going to be in feet. For part B here, we want to know the total amount of fuel that this tank can hold. So for total amount of something inside a shape, we're talking about the volume. And they also told us it was in cubic feet, so that's also a tip-off we need volume. So then the volume formula for a cylinder, that's pi r squared times the height. We already have the radius of 15, half of 30. The height they gave us also is 100. So multiplying that all out on the calculator now. So that's all going to come out to about 70,685.83. And again, that's in cubic feet. For part C, Terrell is planning the design for a new tank that will also be in the shape of a cylinder. When the new tank's full, it holds 2 times the amount of fuel the original tank held. And we're investigating 2 options called designs P and Q. This problem is talking about design P. The radius of the new tank is going to be the same as the radius of the original. We want to know the height of the new tank for P, again, given that this tank needs to hold twice as much fuel as the original. So we'll start with the volume formula, pi r squared h. Now, this time around, the volume that we're going to plug in here, our target volume, is going to be twice the old volume. The old volume was pi times 15 squared times 100. So this will be 2 times pi times 15 squared times 100. Over here, we still have a radius of 15, and we have an unknown height. So again, over on the left, we've got the new volume, and over on the right is what we know about the tank. So all we have to do here actually is just solve for h. Now, if you look at what we've got, we have a pi on both sides. Those can cancel. We have a 15 squared on both sides. Those can also cancel. So h is just going to be whatever we've got on the left side here, 2 times 100, which is 200 feet. For part D, for design Q, the height of the new tank would be the same as the height of the original. We want to know the radius of the new tank in design Q. So again, we'll set up our volume equals pi r squared times h sort of setup here. And let's see. We'll again use 2 times pi times 15 squared times 100 for the new volume that we're trying to target over here. Over on this side, we don't know r this time, but we know h is 100. So now we're going to try to solve for r. First, we have to solve for r squared. We can cancel out the pi's again on both sides. We can also cancel out the hundreds. So we know that r squared then is going to be whatever's left over on this side. 2 times 15 squared. 15 squared is 225. Twice that is 450. So now we need to do r squared equaling 450, so square root both sides. And if we do take the square root of 450, we end up with about 21.21, and that's going to be in feet.